Okay, this is the 1-2 Part B notes in Behavior and Asymptotes. You need to make sure to copy down uh, slides that have the notes. You do not have to copy the examples or the U-turn. However, I would suggest you do so. So the definition in behavior describes what a graph does as x goes to infinity in either direction. So as x moves to negative infinity, what is the f of x doing? That is what the in behavior is talking about. So we always call it x is going to negative infinity, f of x goes to, it's either positive infinity, negative infinity, or to a specific number. And then as x moves to infinity, positive infinity, f of x goes to negative infinity, positive infinity, or a specific number. So again, with our graphs, remember, if you do not see a dot ending the graph, that means it's going to have an arrow at the end. Going off the page means infinity. So does x ever stop when you're moving to the left? So if you're starting at 0 and you move to the left, does the x's ever have a hole or a stopping point? Um, so if not, then what is happening with your y-axis? So as you're moving along this graph to the left, where is the y's going? Are they going down? Are they going up? Are they going to a specific number? So this one, as x decreases, in other words, it's moving towards the negative infinity, the f of x is also decreasing, meaning it's moving towards the bottom of the page. So you can see it's actually a downward slope. As x approaches negative infinity, f of x approaches negative infinity. And this is the symbolic way of saying that. As x approaches negative infinity, so the arrow means approaches, f of x approaches negative infinity. So when we move to the right, starting again at 0, what's happening? Our x's are increasing. Well, what is our y's doing? Our y's are also increasing. They're growing up towards the top of the screen. So as x increases, f of x also increases. And here is the symbol way of saying it. As x goes to positive infinity, f of x also goes to positive infinity. With a quadratic, we're going to see the same thing. When you're moving from the 0 middle to the left, as x goes to the smaller and smaller numbers, what's happening with your graph? Well, as you can see, as we go further out, the y's seem to be going up. So as x decreases, x is getting smaller and smaller, our y's are actually going up, 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 getting bigger and bigger. So they are increasing. As x approaches negative infinity, f of x approaches infinity. And again, the symbolic form of it, as x goes to negative infinity, f of x goes to positive infinity. On the right side, again, x's are getting bigger this time. The y's are also getting bigger. As you can see, it's growing up to the top of the screen. So as x increases, f of x also increases. And again, as x goes to positive infinity, f of x goes to positive infinity. The reason why we look at in behavior is it helps us to identify domain. Here we can see, as we're going to be talking about our domains, we have x is from negative infinity to infinity. Our f of x is basically all going to infinity, and then all we have to do is look for where does it start. Well, in this case, it will start at -2, but what it tells us is where does it end. That's why it's called end behavior. So select the domain and range for the function, and then find the end behavior. We have already looked at the domain and range of this function yesterday. We found out that the domain was all real numbers and the range was from negative infinity to 0. Now we look at the end behavior and see if it matches. So the end behavior, as x goes to negative infinity, our y goes to negative infinity. As x goes to positive infinity, our y goes to negative infinity. So we should have part of the range being it's going to negative infinity, or it starts at negative infinity because it's negative infinity, and it goes to a place, a stopping point. We should also see that our domain is from negative infinity to infinity. If it had gone to anything else, that would have also indicated where our domain would have started or stopped. Okay, asymptotes is a line that continually approaches a given curve but does not meet it at any finite distance. Okay, basically this means is asymptotes is where your graph can approach, but if it's a vertical, meaning north to south asymptote, the graph will never cross it. If it's a horizontal asymptote, the graph will cross it, but only in one specific place. And at the end behavior areas, it will actually approach that asymptote. So when a graph keeps getting closer to a line but never touches, that's kind of a bit a synopsis. So horizontal, what line does the graph not cross from to the left? So if your horizontal is again like the horizon, think of the x-axis as a horizon line. And what is this approaching? Well, if you look at both ends of this picture, in behavior says it's approaching negative infinity. It's actually coming really, really close to the x-axis. And over here, it's approaching positive infinity, coming really, really close, but not touching the x-axis. So the x-axis, y equals 0, is your asymptote. It's a place where the graph can come towards, but can't touch. Horizontally, that's a repeat. Sorry, my bad. The vertical asymptote is going to be from north to south. So again, what is this graph coming really close to? It's coming really, really close to the y-axis, but not touching on both north and south. So as x approaches the negative infinity, f of x will approach, in this case, 0. As x approaches positive infinity, the y approaches again 0, which tells us our horizontal uh, um, asymptote. If we looked at the vertical asymptote, it would be the exact same. We would reverse our statement. As f of x approaches negative infinity, going this way, what is the x's going towards? Well, they're coming towards, but not touching 0. And f of x going to positive infinity, the x's are coming towards, but never touching 0. So a vertical asymptote is y equals 0, x equals 0. Okay, here's an example of your turn assignment. I want you to name the vertical asymptote, and I'm going to give you a hint. A vertical asymptote is the north-south one, but it is named by which axes it crosses. So when you're looking at this, you're not looking at the numbers on the y-axis. You're actually looking at the numbers on the x-axis to name it. Name the vertical asymptote, even though the line that we're talking about is north to south. So which one is this? And it is x is -2. So as you can see, if you look on this side, the line seems to be getting closer and closer to this -2 line. And on this side, it's getting closer and closer to -2. But again, we name that asymptote that we're looking at by which axis does it cross? Well, it's crossing through the x-axis, so it's x equals -2. Your next example is, what is the equation of the horizontal asymptote? And the answer is y is 5. Again, horizontal means east to west, and it is crossing through the y equals 5. We know it's 5 because both the left and the right ends seem to be coming really close to that line where 5 is, but not ever touching it. Okay, so what is the domain of this function? Really nice thing about horizontal and vertical asymptotes is they give us a clue as to what the domain and range is. So if there's a vertical asymptote at x is -2, which we've already established, then that means that x cannot be -2. Okay, so this is the last question, your turn. What is the range of the function in the inequality? And again, use your asymptotes as your clues. In this case, we're looking at the what crosses the y-axis, so that would be a horizontal asymptote. And your answer is y cannot equal to 5 because it's coming really, really close to that 5. It's never actually touching it. Okay. So it's going to be really, really close to coming to 5, but it will never actually touch. So you will not have a x is -2, and you will not have a y answer of +5.